Now we're going to change gears yet again and move into the final chapter of our book, or at least final as far as Calculus 2 is concerned. So this is chapter 9. We'll be talking about parametric curves and polar coordinates. Now, we've spent, well, an entire Calculus 1 course, and now most of a Calculus 2 course showing off different things we can do with derivatives, with integrals. But what is the stuff that makes this work? We need functions. We need functions to take derivatives of. We need functions to take integrals of. What happens if I have a curve which doesn't describe a function, a curve that fails the vertical line test? Here I've got such a curve, x equals y cubed minus y. So in red here, the computer has highlighted every single x, y coordinate where this equation is true. That's what a graph is. However, this graph does fail the vertical line test. You can probably see it with your eyes already, but I want to show off that, yep, there's actually a lot of vertical lines here that will intersect the curve in more than one place. Sometimes they intersect in 3 different coordinates. Sometimes they intersect in just 2. But that is showing me that this curve is not a function. Now, we have actually done stuff like this before. Think back to Calculus 1, where we spent a little bit of time on implicit differentiation. So based off this picture, this does look like a nice smooth curve. And I would expect that I should be able to find tangent lines here. Maybe graphically. Hopefully you remember how to do this with the formula. So I'll pick some point, put a little star on that. And I want to draw a tangent line. It looks like my tangent line will have positive slope. Maybe something like, well, that's a little too steep. It is a little hard to aim these things on Zoom, but that looks like a good tangent line to me. And something that I notice here is that I'm going to have a couple different tangent lines with vertical slope, say here and here. In both of those locations, I can see that my slope is actually going to be undefined. There isn't a real number that I can assign to those tangent lines. So now this curve that I've put on the screen here is a little bit friendly in a way that not all curves will be. So notice the equation that I'm given here, one of the clues that this does not describe a function of x is that I seem to have reversed the roles of my x and y. Here, my y value determines what x can be. So if I were to switch those back, y equals x cubed minus x, well, here in blue is the very same graph, just flipped. I have mirrored it around this 45-degree angle line, right? I just take the mirror image, I switch from one of those graphs to the other. Now in blue, I can do a derivative. I can do calculus, and I can find all those tangent lines and whatnot. However, there will be functions, however, there will be curves that I cannot do this kind of flip trick. But I still want to be able to use tangent lines, to be able to find arc lengths, to be able to find areas. So the point of this chapter is trying to establish the bare minimum for our calculus techniques when the curves that we're interested in do not belong to functions.